Hi, over the next 11 minutes, I will outline how and when to reduce your carbon number. My name is Noel Ainsworth and I am based in Brisbane with the Department of Primary Industries. My background includes working as an extension officer in horticulture, having been based at Mareeba, Brisbane, Gympie and Kingaroy. I would like to start by acknowledging the traditional owners and custodians of the land and seas on which we collectively meet, who've managed this land for the past 65,000 years. If you have already calculated your carbon footprint, it will probably have identified some areas for possible reductions. While every enterprise will have different priorities for reductions, in this video I will cover the 6 most common opportunities to reduce your carbon footprint. Of course, the heaviest use depends on the type of enterprise, but often pumps, compressors, refrigeration and lighting are the first consideration. Changing pumps, installing solar, or hosting a system are 3 options, and there is help and case studies available to help navigate these options. If you're based in the Southern Downs, Goondiwindi, Western Downs, Toowoomba, Scenic Rim or Lockyer Valley areas, Andrew Chamberlain from QFF is already working with quite a few farms offering free energy audits, and he's keen to work with more. But regardless of your property location, you may be interested in the case studies in this link, including Savina Lane Wines at Stanthorpe and Coolmunda Olives at Inglewood. And here are a few more ways to reduce electricity use on farm by improving the efficiency of energy usage and switching to a higher percentage of renewables as a source. In some cases, just riding the wave of the introduction of renewables to the electricity grid might be enough to meet the expectations for improvement by buyers. This will come through in the emissions factors factored into the calculators. In the case of row or vegetable crops, many of you will already be familiar with the benefits of reducing emissions using minimum or less energy-intensive tillage. In terms of fuel use on farm, for some of you, there is now the short-term option of replacing or switching to renewable diesels or blends. These can generally be used in existing diesel vehicles. Their price and availability will probably govern their use. The hydro-treated vegetable oil, or HVO, or green diesel, uses the same feedstocks as biodiesel, but has different production processes. It is chemically identical fuel to ultra-low sulfur diesel, or ULSD, that can be used interchangeably with diesel in current diesel engines, or as a blend with diesel. It can reduce life cycle greenhouse gas emissions by between 60 and 95% per unit of energy. It is usually made from waste cooking oils, vegetable cooking oils, oil mallee, agricultural and forestry residues. The cost, equipment warranties and infrastructure or availability are generally the main barriers to their use. There is also a rapidly increasing range of on-farm zero-emission as well as hybrid vehicles becoming available to reduce or eliminate fuel use. Many autonomous vehicles are developed or in development to reduce fuel use, address costs and/or labour issues. But there is also the fuel use off-farm that for some horticultural producers might be a big component of your product emissions, especially those with calculators that include the Scope 3 emissions, which takes into account delivery of supplies and services to your farm and sending your produce long distances for export. For many industries, the off-farm or supply chain emissions can be up to 95% of emissions in their greenhouse gas account. As you can see here in this graph, there are wildly different emissions depending on the transport mode or modes used to get the produce to the consumer. These averages are the estimates in grams of carbon dioxide equivalent per tonne kilometre travelled. Sea freight per kilometre has about 100 times less emissions than the air freight for the same distance. So selecting what mode or multi-mode approach should not only be based on the cost and convenience of rapid supply, but also into the future, the footprint incurred in that decision. In the future, it will be valuable to know which provider will be switching technologies or fuels to decarbonise their supply chains earlier than other providers. Even for those producers supplying domestic Australian markets, knowing more about the likely timeframes for the decarbonisation of heavy vehicles is of value. There has been some work planning the transition for the transport sector. Here you can see that the timeline for the transition for the heavy-duty vehicles is forecast to be slower than passenger vehicles, with a significant part of the Australian trucks transitioning around 2040 using probably electric and hydrogen cell vehicles. You can either use this or actual plans from your transporters to predict carbonisation timeframes with your supply chain partners. And then the electrification of agricultural machinery may follow the transport and mining sector initiatives. For many horticultural producers, being efficient with your fertiliser can be as much about saving money or about, in some cases, saving the reef. Now, if you're using nitrogen fertiliser in a pre-plant application where you're reliant on rainfall, losses can occur while you wait for the rain. Here you can see the nitrogen conversion process from urea through to nitrate take-up by the plant. Various products exist to slow down that process so that the availability to the plant matches the rate at which it can be taken up by the plant. So investigation identified that there's three options. The first is the use of controlled release products that use biodegradable polymer or oil-based coatings, where cost is currently the main barrier to their use. Urease inhibitors, which can reduce 40% of the ammonia volatilization. Ammonia losses account for about 20% of losses of the ammonium fertilizers applied. And nitrification inhibitors, which can reduce 60% of the leaching losses of nitrate, which is estimated at 20% of what is applied. Alone or in combination, these can reduce the emissions of ammonia and nitrous oxide by up to 50% and the leaching losses of nitrate as well, ensuring more of what is applied gets into the crop. Now, there are also newer forms of fertilizer called amine fertilizers as an alternative to the ammonia or nitrate fertilizers. There is a standard emission factor included in your calculator for fertilizer manufacture. With the growth of large solar and wind projects hosted on farms, localized manufacturing of nitrogen fertilizers might become more commonplace in the future. There are two research projects funded by ARENA investigating urea manufacture using hydrogen. One is being run by Yarra Fertilizers using seawater for electrolysis, and the other is the Eyre Peninsula Gateway Hydrogen Project. There are also 3 efforts underway to produce urea or ammonia using solar. These are in Moree, Melbourne, and San Francisco. It is also worth knowing that some refrigerants have a lower global warming potential than others, so this could be affecting your carbon account. These are built into the calculators. So over the next generation leading up to 2050, you can expect to see a number of decarbonisation-driven transitions in revegetation, energy sources, and production of energy-intensive inputs such as fertilisers. I want to finish this introduction to decarbonisation opportunities by acknowledging the Carbon Outreach project under the Farm Business Resilience Program, which is jointly funded by the Australian Government's Future Drought Fund and the Queensland Government's Drought and Climate Adaptation Program. I would also like to recognise the considerable development of information provided by the University of Melbourne. And finally, if you'd be willing to provide feedback on this video to improve the Carbon Outreach team's understanding of your needs, just use this QR code link. I'd certainly appreciate it. Thank you.